So, hello, good afternoon, ma'am. In this kind of problem, we are asked to determine the neutral axis from the extreme fiber of the beam, um, the required area for the steel reinforcement, and uh, the stress developed in the steel, which is in tension. So, here we go. So, in a reinforced concrete beam, the width is 300 mm and the effective depth of the 600 mm. So given by modular ratio n is equal to 9, and if the maximum stress of 5 megapascals is developed in the concrete when resisting a moment of 80 kilonewton meter. By illustrating the given problem, this is how it looks like. So naatay 300 mm, which is denoted by letter B, small letter b, and then we have the effective depth of the beam, which is 600 mm, denoted by letter D, small letter D. So if we're going to look at this strain diagram, ani nga to ang forma. So from the neutral axis, dito pataas is the compression, in which our concrete experience compression. So with this distance, ang pasabot niya ani actually is from the extreme fiber up to this distance is what we actually call the centroid. The centroid of this triangle in which our concrete experience compression. On the other hand, this distance is actually the distance from the bottom of your centroid of your compression block up to the distance sa ato ang steel reinforcement, which is diri sa atong pinakaubos located. So with that, it is denoted by JD, or let's say Y. So in order for you to determine the distance of the neutral axis from the top of the beam, you can actually use this formula. 1/2 moment capacity is equal to of the concrete is equal to 1/2 times the stress developed in concrete times the KD, or let's just say it's X, times the JD, which is just equal to Y, times the width of your concrete beam. Or you can actually rewrite in this way, in this form. So 1/2 times the stress developed in concrete times the width of the beam times your neutral axis, which is just equal to KD, and then times the Y. Since our Y here is just equal to the effective depth of the concrete beam minus this distance, which is your centroid of your compression block. So we have this formula, and we have this given from the problem. You can actually substitute all of them. So by this moment of 80 kilonewton meter, or is just equal to 80 times 10 raised to 6, or 80 million newton meter, is just equal to 1/2 times your stress developed in concrete, which is just equal to 5 megapascals, and then the width of your concrete beam, and then your K, and then your width of your concrete beam, and times J. This is actually the formula that we used. However, if we're going to use this one, this is how it looks like. This is just the same formula with this formula. With this equation. So we have 80 million Newton meter is equal to 1/2 times 5 megapascals times 300 mm, which is the width of your concrete beam, times X, which is the distance of your neutral axis from the top of the beam, and then times Y, which is your Y is just equal to the effective depth of the concrete beam minus the distance of your centroid from the top of the beam. So that's your Y. So mathematically speaking, this is actually a quadratic equation in which kung imuha na siyang i step by step o step by step sa pagkuha sa imuhang x, we can actually get two answers. So by that answer, we will use 200 mm as the correct answer of the distance of the neutral axis from the top of the beam. Actually, ang katong isa ka answer is actually x is actually 1600 mm, which is it's kinda dali siya mo fit in sa to ang problem kay kung ato na siyang i-locate or somehow layo ra kaayo siya, no? So that's why we use 200 mm as our correct answer. So let's proceed to question letter B. So calculate the required area for the steel reinforcement. So in this kind of problem, what you need to do is just to find the to equate the moment of area above the neutral axis and then below the neutral axis. So diba in this kind of diagram, the above the neutral axis is a compression in which experienced by the concrete. However, in the below the neutral axis is tension, which is experienced by our steel. So by summation of our forces, compression is just equal to tension, in which ang ato ang compression ang direction niya is to the left and then our tension is to the right. So by summation of forces, we have compression is just equal to the tension. So by moment, ingani nga to ang forma. And how did I get this one? Kani. So above the neutral axis, now remember, ang ato ang width sa ato ang beam is 300, and then the distance from the extreme fiber to the neutral axis is just equal to x. So with that, di ba ang formula sa ato ang moment is just equal to force times the distance, which is your force is perpendicular to your distance. And with that, our force, and sa previous na nga discussion, ang force is just actually our area. This is actually a distributed load sa ato ang compression block. So by that, nakay 300 mm times x, and since this is a rectangular form, so and by that centroid, we can actually say that half of the neutral axis, which is 1/2 x. So with that, our moment above the neutral axis is just equal to 300 mm times x times the distance, perpendicular siya, times the distance, which is 1/2 x. So yung ani ato ang forma, 1/2 x. On the other hand, below the neutral axis, which is the tension, now remember, ang ato ang area sa ato ang steel is just equal to n, the modular ratio, which is equal to n times the total area na siya, times the area of the steel, times the distance, which is equal to d minus x. Di kaning d minus x. Nara, this is actually d minus x, where kd is just equal to x. So by moment, n, a modular ratio n times the area of the steel times the perpendicular distance, which is equal to d minus x. So that's how it looks like sa ato ang equation sa pagkuha nato sa ato ang moment of area, both from sa above and then below. So now remember, sa ato ang previous na to nga nakuha, our x, or the distance from the extreme fiber, or let's just say the neutral axis, is 200 mm. So by substituting by mathematical process, so we can get 1666.67 millimeters squared as our area required for the steel reinforcement of the given problem. So let's now proceed to question letter C. So find the stress developed in the steel. So in this kind of problem, what you only need to do is to do the process of ratio of proportion. So by looking at this strain diagram, since this is triangle, so pwede na to siya magamitan of ratio of proportion. This is our neutral axis. Remember, this is our neutral axis. So this one, Fs is mo na itong gipangita. So which means nga mo ni ang na-experience na to ang steel, which is tension, that's the stress nga na-experience sa ato ang sa ato ang steel over the n, or which is the modular ratio. So by that, by ratio of proportion, Fs over n over this distance, neutral axis from this distance, is just equal to d minus x or d minus kd is equal to Fc, which is your stress experienced in or developed in concrete, over this distance from this neutral axis, so which is just equal to x. So by that, ingani nga itong forma nga makuha. So Fs over n over d minus x is just equal to Fc over x. So by substituting all the numbers na natong nakuha sa tong previous, like sa x, makuha na din na nato ang steel makuha na itong stress experience in steel. So with that, na natay value sa to ang modular ratio, na napatay value sa to ang stress experience in or developed in concrete, which is just equal to 5 megapascals, and then your d, or the effective depth of the concrete beam, which is just equal to 600, and then your x, which is 200 mm, or the neutral axis, and same as here. So by that, we can get Fs is equal to 90 megapascals.